Alright, in this video I'm going to show you how to do the Chemistry Moles Test Review 2. So question 1 is asking how many molecules are in 0.35 moles of iodine. So we're going to start with the 0.35 moles of iodine. Now iodine is diatomic, it's I2. It's not really going to matter for the purposes of this problem. If we're trying to go from moles to molecules, in our conversion, we will put moles on the bottom, and the thing we're trying to find, molecules of I2 on top. And the relationship between moles and molecules is that 1 mole always equals 6.022 times 10 to the 23rd molecules. So we put this into our calculator. We take 0.35 times 6.022 times 10 to the 23rd over 1, and that equals 2.11 times 10 to the 23rd molecules of I2. In problem number 2, it wants to know how many atoms are in 3.5 moles of magnesium. So here we're starting with 3.5 moles of magnesium, and we are going from moles of magnesium to atoms of magnesium. Once again, the relationship is the same, that 1 mole is 6.022 times 10 to the 23rd atoms. So here we take 3.5 times 6.022 times 10 to the 23rd over 1, and that equals 2.11 times 10 to the 24th atoms of magnesium, which should kind of make sense. If we have 10 times as much, we should have 10 times as in moles, we should have 10 times as much in the particles. All right. Number 3. If you have 178 grams of sodium chloride, how many moles do you have? So we need to go from grams to moles, where 1 mole equals, well, for the grams, we're going to need the mass of sodium, which is 22.99, plus the mass of chlorine, 35.45. It's 58.44 grams. So in our calculator, we'll take 178 times 1 divided by the 58.44, and that equals 3.05 moles of NaCl. All right. Problem number 4. If you have 160 grams of xenon, how many moles of xenon do you have? So we're going from grams to moles. 1 mole equals, for xenon, is 131.29 grams. So in our trusty calculator, we do 160 times 1 over 131.29, and it's 1.22 moles of xenon. For problem 5, if you have 1.5 times 10 to the 23rd atoms of chromium, how many grams do you have? Well, we don't have a way to go directly from atoms to grams, but we can convert between atoms and moles, and then we can convert between moles and grams. So this is going to be a 2-step problem. So our first step is we're going to go from atoms to moles of chromium, and then we're going to go from moles of chromium to grams of chromium. The relationship between atoms and moles is that 1 mole is Avogadro's number of atoms, and then the relationship between moles and grams is that 1 mole equals 52 grams. So in our calculator, we do 1.5 times 10 to the 23rd times 1 over 6.022 times 10 to the 23rd times 52 over 1 equals 12.95 grams of chromium. It's very important that you either use the E notation for scientific notation on these calculators, or if you're using a times 10 and the little caret symbol, you have to put it in parentheses if you're dividing. Number 6, if you have 1.3 times 10 to the 23rd molecules of ammonium phosphate, how many grams do you have? This problem will work very similar to the previous one, where we go from molecules to moles, and then we go from moles to grams. The relationship between molecules and moles is once again Avogadro's number, which is right there on page 1 of your reference tables. And the relationship between moles and grams is that 1 mole equals, well, we need to take the mass of nitrogen, which is 14.01, times 3, plus the mass of hydrogen, which is 1.008, times there are 12 hydrogens, plus the mass of phosphorus, 30.97, plus the mass of oxygen times 4. So that is 149.096. And then put that into our calculator. Do 1.3 times 10 to the 23rd times 1 over 6.022 times 10 to the 23rd times 149.096 over 1. And that gives us 32.19 grams of ammonium phosphate. Problem 7. How many molecules are in 103 grams of silicon dioxide? So 103 grams of SiO2, and it wants us to go from grams to molecules. So our first step will be to go from grams to moles, and then we'll go from moles to molecules. The relationship between moles and molecules is always 1 mole is 6.022 times 10 to the 23rd molecules. The relationship between moles and grams for SiO2, we're going to need to take the mass of silicon, 28.09, plus the mass of oxygen times 2, which is 60.09. So in our calculator, we take the 103 times 1 over 60.09 times Avogadro's number over 1. And that gives us 1.03. Be careful that you don't miss that it's times 10 to the 24th. In problem 8, it wants to know how many moles is 200 grams of sodium acetate. Well, first of all, sodium acetate is NaC2H3O2, because acetate has a -1 charge, and sodium, being over here in group 1, is a +1 charge. So just one of each of those. And if it wants moles, we just need to do a one-stepper from grams to moles. So we take the mass of sodium plus the mass of carbon times 2 plus the mass of hydrogen times 3 plus the mass of oxygen times 2. We get 82.034. So then we take our 200 grams times 1 over 82.034 gives us 2.43 moles. Number 9. If you have 2 moles of sodium oxide, well, sodium's in group 1, oxygen's in group 16. Sodium's a +1 charge, oxygen's a -2 charge. So we're going to have Na2O. So if we're trying to find grams, we're going to go from moles to grams. We're going to take the mass of sodium plus the mass times 2 plus the mass of oxygen, 61.98. So we're going to take 2 times that over 1. It's 123.96 grams of sodium oxide. Number 10 says what percent of the mass of silver nitrate is silver? So first we need to figure out what silver nitrate is. Well, silver is always a +1 charge, and nitrate, polyatomic ion, it's a minus or -1 charge. So +1 and -1 is AgNO3. So if we want to find what percent of that mass of silver nitrate is silver, well, to find our percent silver, we're going to take how much silver weighs, which is 107.87, divided by how much this entire compound weighs, which is going to be 107.87 plus the mass of nitrogen plus the mass of oxygen times 3. So that's 169.88. So we take the mass of silver divided by the mass of the whole thing times 100 to make it a percent. So we take 107.87 over 169.88 times 100. That's 63.5% silver. Number 11. If you have 155 grams of potassium carbonate, how many molecules do you have? Well, potassium, it's right over here in group 1. It's a +1 charge. Carbonate is a -2 charge. So if potassium's a +1 and carbonate is a -2, we need 2 potassiums. And it wants to know how many molecules, so we need to go from grams into moles, and then from moles into molecules. Moles into molecules is always Avogadro's number. Moles to grams, we're going to need the numbers off the periodic table, so 39.1 times 2 plus 12.01 plus 16 times 3 gives us 138.21. So we put all this in our calculator. And we get 6.75 times 10 to the 23rd molecules of potassium carbonate. All right. For number 12, wants to know what the empirical formula is of a compound that's 38.76% chlorine, 61.24% oxygen. So our first step is percents into grams. Then we go grams into moles. So 38.76 times 1 over, so that's going to be 35.45. So that's 1.09 moles of chlorine. And for oxygen, 16. Take 61.24 times 1 over 16. That's 3.83 moles. So we go percents into grams, grams into moles. Then we divide by the smallest, which is 1.09. And here we're getting 3.5. So we don't have whole numbers here, but to make that into whole numbers, we multiply all of this times 2. So that would give us 2 chlorines and 7 oxygens. So Cl2O7. And then it says, if that compound has a molar mass of 366 grams per mole, what is the molecular formula? Well, we need to go back to this Cl2O7 and see how much this weighs. So we take the mass of chlorine times 2 plus the mass of oxygen times 7, and that weighs 182.9 grams, which is not the 366 that the problem tells us is the actual mass. So we take the 366, we divide it by 182.9, and we get 2. So the actual compound is twice as heavy as this. So that would be, instead of Cl2O7, it would be Cl4O14. Number 14. It says calculate the percent calcium in calcium hydroxide. So to find the percent calcium, we take the mass of calcium, which is 40.08, and then we divide it by the mass of the entire thing. So we take the mass of calcium plus the mass of oxygen times 2 plus the mass of hydrogen times 2. We get 74.096. Multiply that by 100 to make a percentage. Yep, 54.09% calcium. Number 16 says, what is the empirical formula of C5H10? Well, if we just remember that empirical formulas are always the simplest ratio, this problem is actually easier than any other problem on this worksheet. If you remember that ultimately it's just the simplest ratio, well, a 5 to 10 ratio is the same as a 1 to 2 ratio. This is CH2. Number 17, this is a hydrate problem, and this is one that often gives people trouble. All right, so we've got magnesium iodide. Now it's a hydrate, so it's going to be MgI2 with some unknown amount of waters in it. So we work this like an empirical formula problem where we're going to have some grams of MgI2 and we're going to have some grams of water. Well, the amount of MgI2 that doesn't have any water is going to be the amount after you heated it up and drove off the water minus how much that crucible weighed before you started. So we take the 29.44 minus the 19.21. So we have 10.23 grams of magnesium iodide. And then the water is going to be the difference between before we heated it and after we heated it. So that's going to be the 34.74 minus 29.44. So we lost 5.3 grams of water. So now that we have grams, we turn grams into moles. Water's mass is 18.016, and for magnesium iodide, we take the 24.31 plus 126.9 times 2 is 278.11. So 10.23 times 1 over 278.11 is 0.0368, and 5.3 over 18.016 is 0.294. So we went grams into moles, divide by the smallest, which is 0.0368. So we take that and we divide it by 0.0368. And we get what looks to be basically 8. So this means this is MgI2 with 8 waters, or magnesium iodide octahydrate. All right, and there we go.